Hey everybody, welcome back. My name is Jay Gordon and welcome to the Azure Cosmos DB Global User Group. We do this once a month. We get together, we have a great conversation with a member of our community or even sometimes Microsoft full-time employees. And what do? We kind of try to take some looks into real-world implementations of Azure Cosmos DB, especially with people who are pushing the limits, doing great things, really interesting, and basically we want to hear from you. So this is an interactive show. We're going to ask you to give your questions, your comments. We've got that comment section. If you're watching us on YouTube or say LinkedIn, it's right underneath. We will get to your questions. We will get to your comments. And we will make sure you are a part of the show. And because it's your show, we do this for you. And matter of fact, if you want to present at a future meetup, that'd be great. We have this intake form. You can go to aka.ms/Azure Cosmos DB/user group submission, and you can submit what your idea is. I'd love to hear from you. So there's someone I want to hear from right now. We are always happy to have our partners in the Reactor. And today I am talking with Kaylee. Hi, Kaylee. How are you today?
I'm doing great. How are you, Jay?
I'm great. I am so glad you're here to help me out. I always need someone to do a little bit of heavy lifting when it comes to our housekeeping. And so I believe you've got just a couple things you want to share with our audience before we get started.
Yeah. Well, welcome to another Reactor session. My name is Kaylee, and I am the event planner for the Redmond Reactor space. Before we kick off the session, I do have some housekeeping rules I'd like to run through. Please take a moment to review our code of conduct. I will go ahead and copy and paste it into the chat as well. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. And next, we've got our event guidelines. If you'd like to refer back to today's session, you can do so on our Reactor YouTube channel after today's live stream. This session will run about for 1 hour, Please submit your questions through the chat, and we will try to answer as many as possible. Additional learning links will be added to the chat during the session. And it's now time to begin the session, so I'll hand it off to you, Jay.
I'll see you when we're all finished up. Kaylee, thank you very much for your help to get this kicked off. I'll see you soon.
You're welcome.
Well, we got Kaylee in there, and we found out a little bit about what we need to do here in the Reactor. We need to be polite to one another when we're having conversations, and we need you to participate. So remember, if you have questions, leave them in the chat. We'll address them as soon as possible. So what are we talking about today? Well, I think you may know already because you're here. But if you don't know, we're going to be talking today about Azure Synapse Link with Cosmos DB. So let's take a quick look at what we're going to be showing you today. Azure Synapse Analytics Link for Cosmos DB. It enables hybrid transactional analytical processing, HTAP. HTAP, whichever way you want to call it, integration between Cosmos DB and Azure Synapse Analytics. So by using this HTAP solution, orgs can make a decision around operational data in Azure Cosmos DB to be available for analysis and reporting in Azure Synapse Analytics for near real time without the need to develop a complex ETL pipeline. We don't want to do that extra work. We want something to do that work for us. So it's why we implement this way of actually moving our operational data into this service. So we're going to talk a little bit about that today. And I've got a really, really great guest that's going to help me do that. And so today I've got Koen Verbeek. Excuse me if I can't get that right. I apologize dearly. I have this awful New York accent that sometimes mangles names. So I apologize.
Okay.
Welcome.
Yeah, thank you. Thank you for having me as well.
You're welcome.
Honored to be here.
Yeah, we're really glad you're here. You are a member of our community, and we always love having, especially our data platform MVPs, part of this. So one of the things we like to do before we kind of get rolling into the big idea topic is I like to kind of focus on yourself. You are someone that's a data platform MVP, a pro in IT. I'd love to hear a little bit more. So I always ask, how did you get here today?
Well, it all started a very long time ago. I think about 14 years ago. I was always have been a consultant. 14 years ago, I just managed to stumble upon business intelligence. So I've always worked with SQL Server, with the data platform of Microsoft SQL Server. So I did integrate services, analysis services, reporting services. Unfortunately, some SharePoint integration as well. And just, I wanted to learn more. So I started looking at forums, SQLServerCentral.com, for example. Started answering questions. And so gradually I got more and more involved in the community, started speaking at events and stuff like that. And then Power BI happened, and then everything changed. Started speaking at more and more events, started writing lots of articles and blog posts and stuff like that. And I think about 5-6 years ago, I was awarded with Data Platform MVP, and I've been doing it ever since. And yeah, the last few years, we're doing more and more cloud, which is very interesting, very challenging as well.
Yeah. Well, that's great. I'm really glad to kind of get that out of the way. I wanted everyone to know at least who was talking with us. And then you might have seen my buddy Frito joining us. He's going to be in and out, I'm sure. But it's time to kind of get into the big idea, today's subject, which is using Synapse Link for Azure Cosmos DB. Analytics are such a huge part of how we make decisions when it comes to apps, the data that we collect from those applications, and how to kind of prepare for trends. I like to look at this example of, like, let's say it's Christmas time. and the world tends to buy a lot of things during Christmas time, and we may need to do some predictive analysis around, say, how much we're going to spend in postage to ship things. So we can kind of look at the trends on how much people are spending, and then make sure our budget is set properly to be able to do all that shipment. Maybe make sure we have all the right costs based on weight, things like that. So that's just a simple. We're taking the data that eventually comes from our user, we're processing it, and then we're turning it into information that we can read. That kind of leads us into what we're going to be talking about today. So, Kun, if you want to go ahead and bring up your presentation, I can give you the space to kind of get started. And if you have questions, comments, anything, everybody, please just put them in the chat and we'll get to them. But here is the deck. Let's get going.
All right, thank you. So the title of this presentation is Analyzing Azure Cosmos DB Data with Azure Synapse Links and others. So I'll be talking about a few alternatives as well. This presentation I already gave it at a local event called Techorama, which had a jungle theme this year. So this is why some parts of the presentation will be a bit Indiana Jones jungle themed like. All right, very quickly, I already introduced myself. I forgot to mention that I'm from Belgium, so Western Europe. I think that's the most important thing that you need to know. You also notice the Azure Cosmos DB developer specialty because, as I mentioned, I'm a BI developer, data warehouse specialist, the role of data analytics. We're not really well versed in Azure Cosmos DB. So in preparation for the use case I had to do with the client, and for this presentation, I took the certification for Azure Cosmos DB. I followed the whole learning path on Microsoft Learn, and I can absolutely recommend it to everyone who wants to learn more about Azure Cosmos DB to take that learning path and to do that certification, because there's lots of useful stuff in there that you will definitely use at some point in time. So let's talk a little bit about the use case. So what was the reason for this presentation? So there's a client, and they have lots of digital meters, and they meter consumption of natural gas or electricity. So lots of digital meters, and they send their data to Cosmos DB, and they're stored in different containers, one for each operator. So we have different operators who operate the distribution grid in Belgium, and so their data is separated in different containers. And so some sample data is, okay, we have for a certain supplier, for a certain operator, which are two different companies. For a certain meter, we have this kind of data for every day. For each 15 minutes, we have one point in time where, say, okay, you consumed this many kilowatt hours. All right, so the question for today is, how are we going to query this data, and not just point queries, but large analytical queries on top of all of the data? All right, so we're going to talk about a little Azure Cosmos DB recap. Well, I'm sure most of you will probably already know Azure Cosmos DB because you're tuning in the Cosmos DB user group. So I'll go quickly through that. Then we'll talk about analytical store, which drives the Synapse Link feature. We'll talk about the feature itself, and then at the end, we'll also cover some alternatives as well. All right, so Azure Cosmos DB, as you might know, has multiple APIs. You have the document API, key value, column family, and graph API, so Gremlin, Cassandra, table, and stuff like that. And then the documents, this is the one we're going to talk about today. So we're only going to talk about this API, which is referred to as a SQL API, sometimes also referred to as a NoSQL API because it's a document database. This is the only API that matters for today, right? And this API has a database account at the top level. You have one or more databases, which have one or more containers. And inside a container, you have 0 or more items. And one single item is a JSON document. Right. Throughput is determined in resource units, and you can configure it quite dynamically. You can put it on the different containers. You have a maximum of 10,000, if I'm not mistaken. And you can configure this container was 1,000 RUs and so on. So, or you can say on the whole database level, okay, this is the RU throughput for this database, and then just distribute it according to the container how Cosmos DB sees it fit. Or you can mix it as well. So you can have one specific container with a fixed throughput, or the other are more hybrid. So you can mix throughput how you want. And then one of the most important parts of Azure Cosmos DB is the partition key. So we have physical partitions and logical partitions. Physical partitions are managed by Azure Cosmos DB. You don't need to know anything about them. They don't exist for all we care. We only care about the logical partitions, which are managed by the partition key. So for example, in the screenshot here, you can see we have a partition key on username. And you can see that the data is organized according to the first name of our users. Right? And these are the logical partitions. And there's a whole art on how you should choose your partition key. You don't want to use a date, for example, because all of the data for today, for example, will end up in the same partition. You will get a hot partition, you will get throughput throttling or something like that. It's not good. Or if you have a query, you don't want to fan out over all of the partitions, and that your Cosmos DB instance has to read all of the different partitions just to find one single document. So in most cases, you want to choose, okay, our queries, do they filter in a where clause always on the same path of my JSON container? This might be a good candidate for my partition key. Now, if I'm not mistaken, I think in build, they announced that instead of a single path, we can now have more complex partition keys. But I still have to look at all of the announcements. It has been busy weeks with Fabric and everything. But I think they changed how partition keys can work for you. So take an eye on those MS build announcements. And then we have indexing. So everything can be indexed. And here you see an example of 2 items, and every path of the JSON document is put in this tree over here. Right. So an indexing by default is on. You can put it off. You can, and then when you set it to automatic, it's on. And then you can say, okay, I want to either include everything and then maybe exclude certain paths. I don't want to index those, are really not important. Just metadata, for example. Or you want to do the other way around. You want to exclude everything and only include specific parts of the JSON document that you want to index. So if you're a really write-heavy application that writes a lot of JSON documents, you probably want to turn indexing to the last mode, where you exclude everything and only include specific paths. Otherwise, your write's going to go slowly because it needs to index everything. All right, so everything, just one more slide, excuse me. And then we have the change feed. It's a feature of Azure Cosmos DB. So everything that is done goes through the change feed. And you can hook Azure functions to them. This is why they're mentioned in the slide. And they can hook on this change feed, and then you get a feed of like inserts and updates. And previously, deletes were not covered. So if you want to have deletes, you need to do logical delete. Where in your JSON document, you put a flag like tombstone or something like that, or is deleted to 1 or whatever. And then you can detect that something is deleted. But again, if I'm not mistaken, at MS Build, they announced changes to the change feed. Haha, not a pun. And they also said you can have more. I think you have deletes, and you can have like the gross changes or the net changes. Really like CDC change, like how CDC works in SQL Server. And to wrap the recap off, we have the pricing. So pricing is determined by the resource units. So the more throughput you have, the more you're going to pay. It depends on the amount of time all the queries are running. And you pay for storage as well. And storage is quite expensive compared with other tools like just a database or like Azure Blob Storage or Data Lake Storage. This is much more expensive. It's like $250 for a terabyte, or for example, I think in normal Data Lake Storage is like $25 or something like that. So it's a really big difference, right? So don't store terabytes and terabytes of data in Cosmos DB because it'll really start to burn you money. All right, so why did I explain all those things over here, all those features? Because everything you decide on how you set up Cosmos DB has an impact on how your data is structured, how queries run, and how you can run analytical queries. For example, as I mentioned before, the data was partitioned over different containers. So each operator has a single container, and inside the container, the partition key is the meter number. The meter number is a unique number that you can find on your digital meter, and this is how it's partitioned. But we're not, for analytical queries, we're not going to filter on the metering ID. we're going to just take everything for a single day or for a single week and just aggregate it together. So the partition key is no help at all. Also, we have to query over different containers as well. And this is not possible in Cosmos DB, in Azure Cosmos DB. You can only run a query on a single container. So if we want to do this natively, we just have to run the query on all of the containers, get the data back, and then unit all it together in the app. And so it's kind of messy. So we're kind of looking for a more elegant solution here on how we can effectively query all of this data in Cosmos DB, given all of those constraints that I just mentioned. So the savior in our case is our analytical store. Analytical store is a feature of Azure Cosmos DB, and it's very easy to use. You just click, you enable it, and everything is done for you. So you enable it on a container, and the container is transactional row storage, the documents, and it will transform this behind the scenes automatically for you to an analytical store, which is column store. For the people who know column store indexes in SQL Server, for example, it's kind of the same principle. For the people who know Power BI or analysis services, with Vertipack, it's the same principle. Everything is stored as columns, which compresses much better and has less I/O when you don't need to read all of the columns. And everything is done for you automatically. So just enable it, the data is synced, and the storage in the analytical store is, I think it's kind of the same price as blob storage, so it's much cheaper than transactional storage. So you can, for example, just sync the data. It takes a couple of seconds to replicate it, and then you can delete it in transactional store, but keep it in the analytical store, where the storage is much cheaper, and then you can run your analytics on top of this analytical store. And we do this using the Azure Synapse Link feature in Azure Synapse Analytics, and this allows us to directly query using either Spark notebooks or the serverless SQL endpoint this data in the analytical store. So the data stays in the analytical store. This is very important because there are other Synapse Link services who do copy to Synapse Analytics. For example, if you have Azure Synapse Link for SQL Server, it will actually replicate the data from your source database to a dedicated pool in Azure Synapse Analytics. But here, it's not the case. The data stays in Azure Cosmos DB in the analytical store. Just query it directly. All right. So how do we enable it? Well, just click on the link, enable Azure Synapse Link, or you go to integrations, you click on Azure Synapse Link, enable it over there. And the first time, it can take quite some time to enable it. Right. So you just have to wait. But once it's enabled, it's there. You cannot disable it anymore. And then you can choose for which containers you want to enable the analytical store. If it's already enabled and you create a new container, then you have the option to just directly enable analytical store for that container as well. So it's done, Azure Cosmos DB. We've enabled the analytical store. It's all we had to do over there. And then we go to Azure Synapse Analytics. For those of you who don't really know what Synapse Analytics is, it's an integrated analytics platform which has features of Azure Data Factory and Azure SQL Data Warehouse previously, which is now called Dedicated SQL Pools. And it's all brought together in a single user interface for analytics. And we have certain query services, I shall call them. We have Serverless SQL, which is the way to run SQL on top of Parquet files or other data sources. We have Azure Data Explorer, where we can run custom queries on top of our data. Or we have Spark notebooks, where we can run Spark, PySpark or Scala or whatever. You can run it all on top of the data that's inside Synapse Analytics. And for those of you who already, I'm going to mention it again, watched MS Build, we now have Fabric as well. And I think you can call Fabric the next evolution of Synapse Analytics. So I think it's very interesting to see where all the Synapse Link features are going to end up as well in Fabric. All right, so I mentioned serverless SQL pools already. So just a way to write SQL, the SQL we all know and love, on top of data. Data can either be in a data lake, can be CSV files, can be Parquet files, or in our use case, it will be the analytical store in Cosmos DB. You always have one serverless SQL pool. So it's called the built-in SQL pool. And it's all serverless, so you don't need to configure anything. You can create databases, and you can create views and stuff like that, but you don't really need to look at it as a real database. It's just a query engine that can query data on the fly, and you pay for the amount of terabyte processed. So it's not like, oh, you pay for infrastructure or for the amount it's running. Just pay for the amount of terabyte processed. Right. So to get started with our serverless SQL, we first need to create a credential. So he knows he has the permissions to actually access our Cosmos DB. So when you create a linked service to Azure Cosmos DB, and then you can say, okay, give me a NoSQL script, select top 100 rows. It will create a template for you where you can find all of the SQL code that you need to run to create this credential. So you do create credential, give it a name with identity, shared access signature, and the secret is the account key of your Azure Cosmos DB account. All right. Once you've done this, you can just start running queries using the open row set where you specify, okay, this is Cosmos DB, we have this kind of connection, we go to this container, use this credential that we created earlier, and then you get the results just back. The other option that we have is using Spark pools. Spark pools are like Databricks or Spark, and you can run massive multi-parallel programming, whatever, lots of code in parallel, and you can configure multiple nodes, you can configure the size of the nodes. And in contrast with serverless, this is really not serverless. You need to configure how the nodes look like, how big they are, and this will determine the price. Right. And then you can write your code in notebooks, which can either be Spark or PySpark or Scala or whatever. All right. And you can mix languages as well. So using the magic command, you can say, in this box, I want to run some SQL. And if I don't specify anything, I'm going to default to my default language for this notebook, which in this case is PySpark, so Python. So whatever you do, just a warning, there is Git integration. So make sure that your workspace in Synapse Analytics is integrated with Git, because I had this error that you can see on the screen right now. It's a bug. Luckily, it has been resolved now. So I had a long time open support tickets with Microsoft. There were some obscure bugs. If your account was suspended, which is the case because I ran through all my credits, so everything was suspended, and then something weird happens, and then suddenly you couldn't recover my workspace, so it was deleted. So I lost all of my code for my demos. Luckily, I had a backup somewhere. So make sure everything is in Git. You can configure Git integration in Azure Synapse and in Fabric as well. All right, and then when you make a change, instead of hitting save, you need to commit. And after you've committed, it's in the Git repo, but you still need to publish it, so it's actually on the physical server in the Microsoft data center. All right, let's talk a little bit about the demo data. So I have an app, it's called Untapped, and every time you drink a beer, you can scan the barcode, and it will give you more information about the beer. So, okay, this is the name, this is the type, so many alcohol, it's this is the brewery, and so on and so on and so on. So I asked, okay, can you give me more data? But they have an API, but you need to pay for it for some reason. So I just did a GDPR request, and they sent all my data instead. So it was cheaper. They sent me all of my data. I converted to JSON documents and loaded into Azure Cosmos DB. And this is the data that we will be querying during the demos. All right, so let me quickly go.
So before we jump into the demo, do you mind if we maybe take a couple questions from our audience? Great. Let's take this out and let's take a look at some of the questions. We got a few things here and there. Harry asks, oh, excuse me, that's the wrong one. Harry wants to know, and he's curious if this is out of scope. It's fine, but is there any information comparing the HTAP features of Synapse Link to single store or TIDB?
I have no experience with that. Sorry.
Okay, sorry. Harry, get in touch with me on LinkedIn, Jay Gordon, and we'll see about getting you an answer for that. Let's see. Here's another question. Should we change the architecture or approach when using Azure Synapse Link standalone versus using ASL with MS Fabric? I know MS Fabric is very new, so if you're not really sure.
Again, I'm sorry.
Yeah.
I was really curious as well on if Fabric would do the same thing as well. I know they have shortcuts in Fabric.
Sure.
And shortcuts, you just refer to data as if it would be in your data lake. But I'm really not sure how this works. Because there's so many MS Build announcements for Fabric, and Diablo 4, the game was released as well at the same time. Very terrible timing. So I'm swamped. I haven't really got the time yet to delve that deep into Fabric. I'm sorry.
Yeah, no problem. We're also taking a look at one more question. What are the other options to improve Cosmos DB analytical store query performance, like custom partitions?
So I think the question is, if you stay in the transactional row store and you want to run analytical queries over there, how you can improve performance. Is that correct?
I'm not sure, but Jamsiad, if you want to go ahead and pop a follow-up in there, we'll try to get you some answers at some point. So just to remind everybody, if you have questions that don't get answered here today and you want some follow-ups, just find me on LinkedIn. Just use that username. You'll find me, Senior Program Manager, and I am more than happy to get back in touch with you and follow up on any question you might have. I'm really encouraged by all of you putting things in the chat, and always want to say hello and thank you. We've got some really great people, like Sean is watching, Harry is watching, Jamsiad is watching. Thank you all so much. And he was referring to analytical store, by the way.
All right, so in analytical store, the store just is what it is. You don't have any influence on it whatsoever. It just does everything for you. You don't have influence on how exactly it sorts the columns, for example, because that can have a huge impact on compression. There are some things that you can do on the serverless SQL side, for example. I come back later on this on the presentation. You need to make sure you use Unicode because Cosmos DB is Unicode. And I'll cover more of these in the demo. Like, these are things you can do to make it all a bit go more smoother.
Great. So we got about, I'd say about a half hour for you to go into that demo. So let's give you that space back, and I will be back. And if we have any more questions about the demo, I'll pop in and I'll be sure to make sure they get relayed to you. All right, let me bring your presentation back up. You might want to just zoom in a little bit so we can see the documents that you're working with in the browser, but that's really all I got, and I'm going to give it to you and let you continue.
All right, so here we just have my Cosmos DB container. You have different items, and as you can see, they're just JSON documents, some information about all of the different beers. And of course, there are various Belgian beers, because that's where I live. We're very, very famous and very happy with our beers. Anyway, so we've set up the analytical store, just enable it. It's enabled on this container. So if I go to Synapse Analytics, I can have lots of different queries if I go to the correct one. So here, for example, you can see the query where I create my credential. And here I would just run a select star top 100. And then you can see, once I get the results back, how the query store is structured. Right. Of course, when you do a demo, it runs a bit longer than they would normally run. I think there's a bit of a downside when using serverless. The performance is not always that predictable, okay? Because you cannot really tune it with indexes and stuff. It's all done for you behind the scenes. So here you can see this is how the data is returned. We get a row ID, and then we get different columns. So here we see the created add column, which is just a path in our JSON file, is parsed like that. And I think Azure Cosmos DB chose this column as to sort all of the data. It recognized that it's daytime, so I'm going to sort this by date, so it makes sense. And then some columns are still JSON. Right, so here you can see we get all the different beer information. We get the beer name, the beer type, and so on and so on. So some parts are still JSON, while other parts are just normal data now. So we have the rating and stuff like that. So if I want to delve more into it, we need to parse this JSON. So as I mentioned before, we need to write a from open row set clause, but we can specify a with clause. And this is one of the performance tricks you can do to make it a little bit more faster, is that for every column that you want to retrieve, you can say, okay, this is the column This is the data type that you need to expect. You cannot change it, but you can tell serverless, this is the data type from Azure Cosmos DB, so this is what you need to expect. It makes parsing a bit easier. And you can already parse some of the JSON and say, okay, here, this column, you can find it in this path, and this column, you can find it over there, and so on and so on. So you can do a little bit of lightweight parsing as well. And now we can run this, and then, of course, it gives an error this time. Incorrect syntax. Did I change anything? Just going to close it, reopen it. All right, so we cannot change data types in the with class, but we can change it in our normal SQL class with the convert or cast function that we all know. So here we get the results back, and here we can see we now have normal data columns except this one. We have the flavors column, and this isn't just a JSON properties. This is an actual array, so we can have 0 or more items. If there's 0, there should be a null, like you can see over here. So to parse this, we need to use an extra function called the open JSON class. So here I just took those columns, the check-in ID and the flavor columns, the array, and make sure it's big enough. It's varchar 1000. And then I'm going to do a cross apply with open JSON, and I'm going to pass this JSON. And then I can specify another with class. So I have 2 with classes. So the green one from my original, so this is the data coming back from the analytical store. One of the columns, the flavors columns, is still JSON. It's an array. Pass it to the cross apply, and in the blue area over here, I use another with class to say, okay, from this array, I'm going to extract the flavor column. So when we run this, you will see you get one checking ID with multiple flavors. So we just kind of exploded the data, as you can see over here. Right. Now, just to show you, because it was the use case for which I had to create the Azure Synapse Link, you can do a union all query in Azure Synapse Link. So we can query different containers at the same time. The query doesn't really make any sense, actually, and just to show you that it is possible to query multiple containers using Serverless SQL at once. All right. So if I just quickly go back to the slides over here. And when I was creating my demos and in the use case, I noticed some strange behavior. Right, so I had a single item in my container, but when I created with Serverless SQL, I had multiple results. Like I get duplicate results, except I got a different timestamp. But all the data was the same. I was like, oh, what is happening? I had no idea. Why do I get duplicate? Is something wrong? Is it a bug? Well, it's actually a feature, and it's called the time to live. So for those of you who know Cosmos DB, you know it's the TTL. It's a time to live you can set on an item or on a container, and after it expires, the item is deleted from the container. By default, it's off. When you set it on with no default, it means you can set a time to live, and if you want it to happen, you need to explicitly set it on an item. If you set it to on, it's for all of the items in the container. Turns out the analytical storage also has a time to live, which is never off, it's always on, but with no default, which means it will only delete an item if you explicitly set a time to live on an item. So what happened was I deleted all of my items. So just prepare my demo, I was just getting stuff in, getting stuff out, and deleted some items, but they kind of stuck in the analytical store because it kept all of those versions around. Right? So this is something you need to take into account to make sure you don't have duplicates in your data. Make sure your time to live settings are configured correctly. Right. I'm just going to quickly go back to my demo. Let's go to the Spark notebooks, which you can see. And I already run the entire notebook, so you don't have to wait till all of the clusters started and all of the PySpark has run. So I create a database over here. I create a table, and here I refer to my Cosmos DB. Let's say, okay, this is the name of my account, this is the workspace, and check-ins is the name of the container. And here I can just run a select star query as well, just as we did in Serverless SQL, and we get the same data here you can see, okay, we have the same JSON again, and we again have the flavors as well, which are an array. And we can pretty much do the same thing in Spark. So we can read it into a data frame, display the data, and then we're going to do an explode, which is, oh, sorry, I got a little loading screen. So we're going to explode the data, which is the same behavior as the open JSON class. We're just repeat the row for each item of the array. And then we're going to drop all of the columns we don't need. So here we can see we have, for each item, we have like 3 or 4, kind of depends on how many flavors there are. We get a row. So we get data repeated, and then for each row, the different flavor. Then I'm going to add some year, month, date, and so on. Because actually, the client had a question, okay, so we want to analyze data. We can use the analytical store, but is it possible to do some lightweight ETL on this? So we can store the data formatted or partitioned by, not by the distribution grid operator, but by the supplier, right? So I tried it with Serverless, and it didn't really work. So I tried it with Python here as well. And this is why I added some year, month, date, and stuff like that. So I can neatly partition my data. All right, so I just add some year, month, date to my data. And here I say, okay, I'm just going to override partitions if they already exist. Repartition 1 means I only want one Parquet file. If it exists, override it. Partition by year, month, date, and put it in this folder over here. So if I run this, so every Synapse Analytics has an integrated data lake storage. So I can go over here and look at all of the data. And here in the folder, you can see that I've taken all of the data from my analytical store and wrote them out as Parquet files in my data lake over here. So here you can see I have one single Parquet file. So with Spark Notebooks, I could resolve my use case where I say, okay, I want to take the data from Cosmos DB and store it in a different format very easily, just writing a short notebook. Right, so the problem of Synapse Serverless SQL is that it's not an ETL tool. So you can create an external table. So it will create some Parquet files and it will reference it as a table, but you cannot override it. If you try to run your SQL statement again, it will fail saying the table already exists. And when you try to delete the table and run it again, the Parquet file still exists behind the scenes and will fail again. So this is why serverless SQL pools are not an ETL tool. They're sort of like a lightweight query engine to get your data, or they can serve as a pass-through to another tool like Power BI. So you can hook up Power BI to a serverless SQL pool, which will query Synapse Analytics analytical store. So Power BI goes to serverless SQL pool, which on its turn goes to the analytical store. As I mentioned, there are some specific performance optimizations when you use serverless SQL for Azure Cosmos DB. Make sure it's all in Unicode, explicitly set the schema using the with clause, obviously filter data as soon as possible, and not just link to some extra resources from the Cosmos DB team, the Azure Cosmos DB team, when you query with Synapse Link. And they have some store procedures and stuff like that. They can run and it will check everything and make sure it's all best practice. Right. So are there any questions? Because now I will dive into the alternatives.
At the moment, I don't see any particular questions, and we got about 15 minutes left. So if you want to go ahead and get into your alternatives, feel free. If anyone does have questions or comments, just leave them in the chat. And like I said, if there's something we can't get to, our friend Harry has already sent me his questions. I've already relayed them back to the product manager. So we're all set there. So I'm going to let you kind of finish up and then we'll close out. Sound good?
All right. So alternatives, just dump the data somewhere else. Take it from Azure Cosmos DB and put it in your data warehouse, data lake, or lakehouse, or whatever. You can do it maybe by the original process that inserts in Cosmos DB also insert someone else, but then it might get complicated. What if there are updates and deletes, and then you need to duplicate logic? So you probably want to avoid that scenario, which was the case with my client. So another idea is just read the data with whatever ETL, ELT tool of your choice, store it again in whatever destination that you like, which can be Azure Data Factory, for example. But Azure Data Factory itself, when you use the copy data activity in a pipeline, it can have some trouble with complex JSON. So you can maybe do binary copy or something like that. But if you want to handle the JSON, you probably want to look at the data flows feature of Azure Synapse Analytics, which I guess is also available in Fabric as well. Oh, that was the wrong button. All right, so we have another cool feature. It's called Azure Synapse Link for Azure Cosmos DB to Azure Data Explorer, which is currently in preview. So Azure Data Explorer is a time series database, which some of you might know if you use Azure Monitoring and you write the KQL queries or the custom query language queries. This is kind of like Azure Data Explorer behind the scenes. So you get data in Azure Data Explorer, and you can run this custom query on top of your data as well. And it's really useful for analyzing big amounts of data, big volumes of data, and especially time series data. So there's a Synapse Link feature for that as well. Why, you might ask, is it called Azure Synapse Link when it's not in Synapse, but actually in Azure Data Explorer? Well, there are Data Explorer pools in Synapse. They're also in preview, but they don't support this Synapse Link feature yet, I suppose. I have no idea if it's coming, if it's in the pipeline or not. But Azure Data Explorer itself, in the early days, was planned to be released in Synapse Analytics, but they released it earlier. So we now have Azure Data Explorer and Synapse Analytics next to each other. But Synapse Link is the name for all of the replication features for data. So this is why it's called Synapse Link for Azure Cosmos DB to Data Explorer. All right. As I mentioned, there are ADX tools in Synapse, but they don't support this scenario yet. So in Azure Portal, you can create an Azure Data Explorer database. You can give it a name, and then you need to specify 2 retention periods, one for the normal data, a bit like the time to live in Azure Cosmos DB, and also a retention period for the cache. So it kind of keeps a cache automatically of frequently queried data for you to speed up everything. Right. And then you can run query, custom query language or KQL queries on top of the table over there. All right. So to make it happen, we first need to create a table. And it's not SQL because it's .create table. So this is how you know it's KQL. And after we've created a table, we need to specify a mapping. So the mapping says, okay, for this column of the table, it's this part of the JSON. This column of the table, it's that part of it, and so on. It's basically the same principle as a with clause in the serverless SQL query. It's the same principle. Just map every column to a path of your JSON. Once this is done, you've created a table, you created a mapping, you can create a connection to Azure Cosmos DB. So you specify the name, subscription, Cosmos DB account, database container, which table in ADX you want to use as a destination, and which mapping that you just created. And then it uses the change feed that I mentioned in the beginning of my presentation. It uses that change feed to get all of the data. So you can say, okay, I only want data for the last week or the last year or the last month. You can specify a retrieval start date. If you go way back, it might take some time till all of data is copied to ADX. And this is the biggest difference with the other Synapse Link feature. Here, the data is copied physically to ADX. While with Synapse Link in Synapse, with Serverless, it is with Serverless just a live query. So the data stays in the analytical store. On the other hand, if you use Spark pools and you create a data frame and you write it out, of course, the data is copied there as well. All right. So let me quickly go to Azure Cosmos DB. My cluster is already running. It will turn itself off after 5 days if you forget to shut it down, and you cannot change it. It's always 5 days. So here we have our create table. Hide this one over here. Make this a little bit bigger. And make this a little bit more smaller. So here we just have a create table statement, which kind of looks like the hybrid of .NET and SQL. Just basically a create table, column names, and data types. Then we create our mapping, bit of a curious syntax with all of the ticks over here. But we just like in the with class, we just specify which column maps to which JSON. If you really want, you can do some very, very lightweight transformations here, but only on datetimes. As I mentioned, it's a time series database. So if, for example, the source data has a Unix timestamp, or what is it, the number of ticks since 1970 or something like that, you can already change it to a normal datetime here in a document mapping, but it's only very lightweight. And then we can just start querying the data. Once I've already copied all of the data over, it uses a change feed, so it's kind of real time with a bit of a delay that the data is copied to ADX. So we just selected all of the columns, and just like with Serverless SQL or Spark, this is the data that you get back, the same data. And we can write some KQL queries. We can do a count on the table, or we can do give me the top 10 most recent ones, or you can even do a summarize, which is sort of like a group by in SQL. And here we get a nice chart of all of the beers that I checked on. It's all possible. And here I do a bit of the same thing as I did in Spark and in Synapse Serverless. In Synapse Serverless, it was OpenJSON. In Spark, it was Explode. Here it is called the NV expand. It's where I take an array in my JSON and then just expand it so I have a row for each item of the array. All right. And then extend is add a column, and project away is delete a column. So if I run this, you get, again, the same results as in all the other data. Luckily, we get the same results. All right, so this is KQL. Azure Data Explorer, it's quite new. I don't think it's really that well known yet, but I think it's really, really promising. You can put some ETL processes in there as well. I forgot the name of the feature, but you can copy data between tables in ADX as well, and then you can do some transformations there as well. So you can, if you really want to, you can create some sort of a lake house, data warehouse type of structure in ADX as well, or you can use it like Serverless as a pass-through to another tool. So you can hook Power BI to ADX and then run your queries on the data that's in ADX. All right, so just to wrap everything up, so what is the difference between Serverless and ADX? Well, for Serverless, it's Serverless, so you don't need to specify any hardware specification. While with Data Explorer, you need to specify a cluster. With Serverless, you just pay for the number of terabytes scanned. While Data Explorer, you pay for the amount of time the cluster is running and the storage. The storage cost, I think, is basically the same as data lake storage, so much cheaper than storage in Azure Cosmos DB. Serverless uses SQL. Data Explorer uses KQL. Data stays in the source, as I explained, while with Data Explorer, data is copied to ADX to the append-only table. But as I mentioned before, you can put some lightweight ATL, so you can do more merge kind of scenarios in other tables in ADX. Both can be used for ad hoc analysis or as a pass-through to other tools. The final alternative, which I'm just going to very lightly touch in this presentation, is you have the data flow in ADF, which is basically Spark with a user interface on top of it. So for people who have been working with integration services, and they know the data flow, it's basically the same thing. You have little boxes, you have arrows between the boxes, and you have a source, you get some transformations, and you have a destination. But in contrast with SAS, here it's all translated to Spark behind the scenes. So here we're going to say, okay, we're going to read from Azure Cosmos DB. We're going to use analytical store as well. And then we can say, okay, capture the leads or whatever, and it will read the data from the analytical store. And then you can copy to whatever destination as you want. So in the area of data flow, you also need to specify a cluster. So it's not serverless. You pay for the amount of time the cluster is running. In contrast with all the other options, this one is no code or very low code. You can write SQL if you really want to, while the others are more technical in nature. The data is copied, from the analytical store, and you need a destination. So it's not a query engine like all the others. It's ETL tools. You get data from the source, do something with it, and then write it to some destination, whatever that may be. So to wrap everything up, so there are multiple options to read or analyze the data from the Azure Cosmos DB. It kind of depends, as usual, on your scenario. Do you want to keep the data in Azure Cosmos DB, just enable analytical store and query directly, or just copy the data to somewhere else, right? I think the cheapest option is probably serverless. You could just pay for the amount of terabytes scanned. So it's not, and I think, if I'm not mistaken, it's around $4 per terabyte. Don't quote me on that, or I'm not really sure, but it's a very low amount per terabyte scan. ADX might be a good contender as well for the cheapest option. It kind of depends how you set it up. And as usual, test for your use case. So that was everything on my end. So if there are any questions, I think now is the time.
Yes, right now I think we are without questions, but I will ask everyone, if you don't mind, please ask them. We've got just a few minutes left. I'm going to ask you if you could do me a favor. Would you mind bringing up your contact slide so people can know how to get in touch with you in the case that they have questions or they want to follow up, they want something about your demo. I want them to be able to reach out to you directly.
Right. So you can find me on LinkedIn, Koen Verbeek, on Twitter as well, on Mastodon even. I have my own blog at sqlcover.com. I think if you go there, and I think one of my latest blog posts was for Techorama, where I said, okay, you can find the slides over there as well. So everything is clickable, the link, so you can access all the resources. And I think they're also in the show notes for this session, if I'm not mistaken.
Yeah, and if you want to send me a link to the slides, I'll pop them in the show notes as well. So easy enough. I think we're just about at our end. And to be honest, I think you did an amazing job. I think we learned a lot today, and I really appreciate you being part. Our community is so important in order to let people know about it's all these things are possible. And you just need to put the time in to learn about it. And that's one of the things you provided to us today. You gave us a roadmap, kind of how to take our analytics from, say, Azure Cosmos DB, from that data, and bringing it into Synapse, and really being able to make it easier by not having to create these pipelines on your own, and to basically be able to get that information so that you can make big decisions about what your data is telling you. So that being said, I want to bring in Kaylee. Kaylee, if you want to turn your camera on, I will bring you back into the stream. There you go.
Thanks, Jay.
No problem.
Yeah, I just wanted to thank everyone and thank the speakers for today's session. The survey has been posted in the chat. If you want to go ahead and fill that out. The Reactor is always looking for unique sessions and different topics that we can drum up to the community. So yeah.
Great. And I know we've got another really great session next month on July 11th. We've got Leonard Lobel. He is a spectacular presenter, has done a lot of really great stuff on data modeling, and kind of to fit in, we talked a little bit about change feed today. He's going to go a little bit deeper into that change feed, maybe look at some of the new features and really get you up to speed. So that being said, I want to thank you very much, Koen. It was really great to have you. Kaylee, thank you so much for being here for us and helping facilitate these sessions. Our Reactor partners are so important. And there goes the outro music. So I think it's time to give a big wave goodbye to everyone. Thank you so much. We really appreciate you being part. We'll see you next month. If you've got more questions, concerns, like I said, just reach out to me on LinkedIn and I will get back to you. So until then, thank you, everybody, and we will see you next time. Have a great rest of your week, and we'll see you soon.